Hello, geometry students. Here we're in section 4-1, and we have some new vocabulary. We have acute triangle, we have equal angular triangle, an obtuse triangle, right triangle, equilateral triangle, an isosceles triangle, and scalene triangle. Okay, an acute triangle has three acute angles. An acute angle is under 90 degrees. So every angle here is under 90. An equal angular triangle, three congruent acute angles. And since there's 180 degrees in a triangle, that means that each angle here has to be 60 degrees. They're 60 all the way around, so they have three congruent angles. And then an obtuse triangle has one obtuse angle, which is an angle that is more than 90 degrees. And then we also have a right triangle, which has a 90-degree angle as one of its angles. Classifying the triangle as acute, equal angular, obtuse, or right. So you can see that they're all 60 degrees here. So the triangle has three congruent angles. It's an equal angular triangle. Classify the triangle as an acute, equal angular, obtuse, or right. Well, notice here that it does have an angle that's more than 90 degrees, and so that would be obtuse. All right, check your progress. We have the frame of this window design is made up of many triangles, and we like to classify triangle ACD. So it's this kind of triangle here on the side, okay, this triangle right here. And so you can stop your video, and if you said obtuse, you were correct. The reason why it's obtuse is because angle ACD is more than 90 degrees. Okay, now we're looking at the triangle ADE. So ADE is the triangle. Okay, give you a little hint there. Go ahead and stop your video. And you're right, it's a right angle. It's a right triangle. Okay, now we're going to classify triangle X, Y, and Z. X, Y, and Z. Okay, we need to explain our reasoning. Well, since our triangle XYZ, we can take these two angles and we're allowed to add them up and we get 90 degrees. Then we can say by the angle addition postulate, as we saw on Mathia, that you get 90 degrees for the sum of the two angles, therefore it is a right triangle. Alright, we're going to classify triangle ACD as acute, equal angular, obtuse, or right. And this is checking your progress, so go ahead and stop your video. And if you said acute, you're right. It's acute because every single angle is under 90 degrees. Okay, classifications of triangles by sides. So we also have an equilateral, lateral meaning side. So this has three congruent sides, and when something is congruent, we show it by a tick mark. Okay, and then we have isosceles, and isosceles says at least two congruent sides. So since it says at least two congruent sides, so a equilateral also is an isosceles. But an isosceles triangle is not necessarily an equilateral. As we can see here in this side is not the same length as the other two. And then we have scalene. Scalene, no congruent sides at all. Okay, classified triangles by sides. Here's a real-world example. The triangle truss shown is modeled for steel construction, and we're going to classify triangle JMN, and that's the large triangle, and we're going to classify JKO. It looks similar to JMN, but it's just a little smaller. It's just a little triangle here. And then we're also going to look at the triangle OLN, okay, which looks pretty close to being equal angular. Right. So JMN has one angle with measure greater than 90, so it's obtuse. Triangle JKO has one angle with measure equal to 90, so it's a right. So we were off a little bit. So this is a right triangle. Okay, it's hard to tell that. And here is this angle here is larger than 90, therefore it's obtuse. And then we have the other one that they're calling an acute triangle with all angles congruent. So they're calling it, like we thought, equal angular. All right, coming back here to our little window, check your progress. Classify triangle ABC. Go ahead and pause your video. If you said acute, you're correct. Now, you might have also thought maybe equal angular, but it may not be exactly that, but definitely all the angles are less than 90 degrees. Okay, so here we have if point Y is the midpoint of Vx. Okay, now it says Y is the midpoint, so we have to, don't assume by the picture, because it looks like it's not the midpoint. But if it is the midpoint, okay, then I wonder what the sides here would be. Okay, so the YX should be half the length. Same thing here with the VY. That should also be half the 8.4. Okay, and so we're just trying to decide if this is equilateral. The VWY, well, VWY definitely is not equilateral because 4.2 and 4.5 aren't the same. Isosceles has to have at least two sides the same, or scalene. Okay, I bet it's going to be leaning towards scalene. Let's check it out. By the definition of midpoint, right, we have the segment addition postulate. Therefore, by substitution, M together, like we said, we get 4.2. Okay, so we know that WV is 4.5. Since all three sides have different lengths, the triangle is scalene. WY equals 3 units. I think I must have missed that. Oh, it tells us right there. So WY is 3. Let's put that here. Could have got that right away. So I guess I just have to read. So even your teacher made a mistake, but here we go. All right, WY equals 3 units. Okay, so we know they all have different sides, so it's going to be scalene. Okay, check your progress. If point C is the midpoint of BD, okay, point C is the midpoint of BD, then we know this is going to be 1.7. and this is going to be 1.7. Okay. Let's go ahead and pause your video. Is this equilateral, isosceles, or scalene? Okay, isosceles. The reason why triangle ABC is isosceles is because of this little red mark. This little red mark indicates that the segment AC is congruent to segment AB. Therefore, triangle ABC has two congruent sides, therefore it is, or at least two congruent sides, therefore it is isosceles. Find the measure of the sides of the isosceles. So as soon as they tell me it's isosceles, okay, with triangle KLM with base KL. So we know that at least two sides, or isosceles, have the same. So if they're going to be the same, then we're going to be setting these equal to each other. So we're going to find D. We're going to set KM equal to ML. So 4D minus 13 equals 12 minus d. And then we're going to solve for d by adding d to both sides and adding 13 to both sides and then dividing by 5. So we have a value of d is substituting back in from 5, and we plug it in, and says ml equals km, therefore km is 7. And kl is d plus 6, which was given in the picture, and therefore, since d was 5, we have the two congruent sides are both 7, but then the base that they called KL is 5 plus 6, or 11. Alright, let's check our progress. Find x and the measure of each side of equilateral triangle. If AB equals 6x minus 8, BC equals 7 plus x, and AC equals 13 minus x. Notice it says equilateral. Go ahead and pause your video to check your answer. Okay, x equals 3 and all sides are equal to 10.